So we will do together some problems on chapter of work and energy. We already introduced all the formulas and we'll start to do some practice. So if you look at this problem, a 10 kilogram block rests on a smooth incline. If the spring is originally stretched 0.5 meters, determine the total work done by all forces acting on the block when a horizontal force P of 400 Newton pushes the block up the plane a distance of 2 meters. So in this problem, you have a block. This block is attached to a spring. And initially, they told you that at the initial state, the spring was not unstretched. It has a certain stretching of 0.5 meters. So this is state 1. For state 1, you know delta L. So delta L1 is equal to 0.5. And the block starts from rest. Since the block starts from rest, so the velocity of this block is equal to 0 at state 1. Now, at the final state, we have a displacement of 2 meters up. So at state 2, we should find what will be the total work done by the spring when we move it 2 meters, okay? And from here, they can ask you what will be the velocity of the block at state 2. Okay? So now, to start with, we should draw the free body diagram of forces on the block to know what are the forces acting on it. So first, we have the weight. We have the spring force. You have the normal reaction. Here they said the smooth, we have a smooth incline, okay? So no friction. If they told us that we have a rough surface, then we should take into consideration the friction force, okay? So now once we determine the forces acting on the block, we can calculate their work. To start with, for the normal, what is the work of the normal here? What is the work of the normal force on the block? Can you repeat, please?
0.
Yes, it's 0. Why it's 0? Because the normal is perpendicular to motion. And we know that a force perpendicular to motion cannot produce any work, okay? So first we can start by saying that the work of the normal is equal to 0, okay? Now, the second force is the weight. For the weight, you can do two methods. Or you project the weight on the direction of motion. So if I project the weight, so this is the weight is always vertical. This is the direction of motion. If I project the weight on the direction of motion, it's opposing motion. Okay, so it will do a negative work because my block is moving up and the projection of the weight is downward. Okay, so to find the component of projection of the weight, I just have to find the angle here. I know that the angle of the incline is 30 degrees. So I can deduce that this angle here is 60. So to project the weight on the incline, or I do W cosine 60, or I do W sine 30. Okay. Now, to find the work of the weight, as we said, since the projection is opposing motion, so it's a negative work. So I put minus W sine 30 times the displacement delta S times delta S. The displacement delta S is equal to 2 meters. So I replace delta S by 2, and the weight is M times G. So I can calculate the work of the weight. Okay. Now, another method to calculate the work of the weight, if you remember, when we defined work of weight, we come up with a formula. The formula for the work of the weight is minus W delta Y. If I consider y-axis vertical upward. Okay. So if I want to use this formula, I can do it because I know the initial position, position 1. I know the final position, position 2. Delta S is along the incline. So this is delta S. While delta Y, okay, delta Y will be this distance. Okay. So since my block is moving upward and Y is positive up, delta Y is positive. So I can write that this distance is equal to delta Y. And I can calculate it because here I have a right triangle and this angle is 30 degrees. And the distance of displacement of the block is 2 meters. So delta Y is equal to 2 sine 30. And now if I replace, yes?
What are we projecting to what?
No, we are not projecting. If you remember, when we derived the expression of the work of the weight in class, what was the formula? Work of weight equal to minus W delta Y. Do you remember this formula? So this is another method to find the work of the weight. The first method is to project the weight on the displacement direction and then multiply by delta S. The second method is to use the formula developed in the course, which is that for any displacement, the work of the weight will only be affected by the vertical displacement of the object. It will not be affected by any horizontal displacement. So here, delta S is decomposed into two parts, a horizontal displacement that will not affect the work of the weight, and a vertical displacement, okay? If you want to use the formula developed in the course material for the work of the weight, you should find the vertical displacement. And the vertical displacement here is this distance. To calculate this distance, you say this angle is 30 degrees. This distance is 2 meters. It's the hypotenuse of this right triangle. So I can do 2 sine 30. Okay? And now if you replace in your formula, you will end up with the same result that we found with the second method. So you will find that the work of the weight is minus mg times 2 sine 30. Okay? Was that your question? Do you hear me? Okay. So now, the other forces we still have to find the work of are the spring force and the force P. Okay. Now, for the spring force, whenever you have a spring, you can use the formula developed in the course material. The force of the work of the spring force is equal to half K delta L1 square minus half K delta L2 square.
هلا ال1 هي delta L1 هي الانيشال.
Delta L1 هي initial stretching and it's given. Okay? They told you that the spring is originally stretched 0.5.
هي الانيشال مع الفاينل تيتشر؟
نعم.
هي الانيشال مع الفاينل؟
هي الانيشال minus الفاينل. Yes. Half K delta L1 square minus half K delta L2 square. And delta L1 is given. How to calculate delta L2? Who will give me the value of delta L2? What is the final stretching of the spring at state 2, delta L2?
Two?
No, not 2. Look, why it's not 2? Because originally when you were at this position already, delta L was 0.5, okay? And now you are stretching more. Yani you are adding 2 meters of stretching in addition to the 0.5 meter. So what will be the total stretching? The total
2.5.
stretching is 2 plus 0.5. It's 2.5. So delta L2 is 2 plus 0.5 equals to 2.5 meters. Okay. And since I know the stiffness K is given, and I determine delta L1, delta L2, all I have to do is to replace back in this formula. And do you expect that the work of the spring will be positive or negative?
Negative.
Positive. Okay.
Look, when the block is moving up, the spring is doing on it an action downward. So it's trying to oppose its motion, okay? Because when you are increasing the stretching of the spring will do on you a force in the opposite direction. So it will, this will lead to a negative work because you are trying to moving up while the spring is trying to push you down, okay? So you, and you are increasing the stretching effect. If you were decreasing the stretching, yani, if you move in the downward direction, then the work will be positive. Okay, but since you are moving up, then the spring is opposing your motion and it will do a negative work. So until now, the normal has no work. The weight has a negative work because it's opposing motion. The spring has a negative work also. The only force which will do a positive work is P, because P is the force that was needed to push the block upward. Okay, if we don't apply it, the block will not move up. Now, how to find the work of P? What should we do?
اول شيء طلعنا الورك
لحظة.
سبرينج مش هيك؟
ممكن حكيني بالشات
تيتشر
محمد شيء مش الحال محمد.
مش الحالي مش الحالي.
Okay. So for P, you always have first to project the force on the direction of motion. Okay. You have here a constant force doing in magnitude, doing a constant angle with the direction of motion. This angle is equal to 30 degrees. So all you have to do is to project your force along the direction of motion. And as you can see, the projection of P is in the positive direction of motion, so it will do a positive work. The projection of P on this direction, you can just do P cosine of the angle 30 and multiply, because it's a constant force with a constant angle, the work of this force is P cosine 30 times the displacement delta S. Okay, so I can say that the work of P is equal to plus P cosine 30 times 2, which is the displacement. Okay. Now, after I found the work of all forces, I can do the summation. And you expect that the total work will be positive or negative in total when you add the work of P, the work of W, and the work of the spring. What do you think? The total work will be positive or negative?
Negative.
Why negative?
شو هو السؤال؟
عم قول إنه when you add work of all forces, the total result will be positive or negative?
ما فهمت.
Okay, look. نحن we did calculation of individual work of forces. Now, when I do the summation of work from state 1 to state 2, I will add the work of P which is positive, plus the work of the spring, which is negative, plus the work of the weight, which is also negative, and the work of n is 0. Okay? And from the principle of work and energy, sum of work between 1 and 2 is equal to what? Is equal to the kinetic energy at state 2, KE2, minus KE1. Okay? Since you were able to move your block from rest, and your block initially at state 1, V1 is 0. As you are moving upward, now your velocity V at this stage has a certain value, okay? And this value is positive because you are moving up. When you stop, you will reach a certain time where you will stop. You can calculate this time, but here in this problem, you can still continue to move. How you can make sure of this? When you do the calculation, the kinetic energy at state 2 will be positive, of course, because V, you have a velocity at this stage. At stage 2, you still have a velocity. Now, the minimum velocity you can reach is 0. Yani if you continue to move at a certain location, your block will stop. Why it will stop? Because at a certain location, the spring maybe will be able to overcome the work of P. So they can ask you for which location my block will stop. You can do your calculation and know what will be this position, okay? But at this location, S equal to, you can find that the result, total result is positive, and you can say now I can calculate what is the velocity at this point. Now, if they ask you at which location will the block stop, what should you do? You should say, I want to find what is the distance S required to stop my block, okay? You can write your equation. We'll do it together as an example. And we can find what value of S correspond to V equal to 0, okay? Any question on this part before we do the extra question? Okay, so I will add a question. For which position, okay, the block will stop? So I want to find if there is a position S for which the block will not be able to move upward anymore. So if the block will stop, then I can say I will define the state as state 3. I want to find the position S3 for which my block will stop, okay? So because it will stop, then V at 3 will be equal to 0. And now I can apply.
Sorry. Sorry. عندنا الأسطول نحن.
Can you please repeat?
الأسطول معنا إياها نحن.
الS3 نحن بدنا نجيبها. It's not given, okay? يعني أنا عم بعطيكم an additional question. عم بسأل for which position، يعني قد ايه بده يطلع البلوك، قد ايه maximum البلوك بيقدر يطلع. What is the maximum distance as the block can move؟ شو يعني؟ يعني تكون maximum distance يعني بده it should stop، okay؟ بيوقف وبيرجع بينزل البلوك. So I want to find if there is a position S for which the block will stop. This will correspond to a velocity of 0, okay? So I should express now work of all my forces function of S3 to calculate S3, okay? So I will repeat the same work, but now I know the final velocity, but I don't know the displacement S3, okay? So if I want to express again the work of forces, if I do a displacement of S3, to start with, the work of the normal will still be 0. Now, for the weight, I will do the same method I did before, okay? Which is when I project the weight, I have a negative projection. It's opposing motion, okay? Because motion is up and the projection of weight is down. So it's minus mg sine 30. Now, what will be my displacement? It is S3. Okay, so I will express the work of weight function of S3. So it's minus mg sine 30 times S3. Now, for the work of the spring.
ليه times S3 بس؟
نعم بس S3 لأنه شو الديسبليسمنت تبعك أنت؟ أنت you started from this position وطلعت لفوق a distance of S3 صح؟ يعني what is your displacement?
S3 okay.
Okay. Now, for the work of the spring force, what is the formula, the general formula between 1 and 3? It is half K delta L1 square, the initial stretching of the spring, minus half K delta L3 square. Okay. Now, delta L1, I know it already from the previous step. Delta L1 is 0.5. What is delta L3? Who will tell me? What is the value of delta L3?
Zero.
No, look, give zero, guys. The spring can initially stretched هون 0.5 صح؟ وأنا زدت على هيدا stretching a value of what؟ يعني هو already stretched 0.5 وأنا زيادة مشيته لفوق a distance S3. يعني what will be the total stretching?
S3 plus 0.5.
Yes, very good. So delta S3 is S3 plus 0.5. Okay. Now, for the work of, I still have the work of P. Okay. For the work of P, function of S3, it's the same method we did before. So we project P on the direction of motion. It's a positive projection. So it's plus P cosine 30 times the displacement. What is the displacement? If I move from this point to point 3, what is the displacement? It's equal to S3. Very good. So now I expressed the work of all my forces function of S3. And I know that at point 3, the block will stop. The velocity is 0. So to find what is the value of S3 for which the block will stop, I will apply the principle of work and energy. And I will say that sum of work between state 1 and 3 is equal to the kinetic energy at state 3 minus the kinetic energy at state 1. But both kinetic energies are equal to 0 because for the initial state, it's starting from rest. And for the final state, it will stop. So my equation will be sum of work is 0. And if you look at your expressions of work, you will obtain a second degree equation with respect to S3. Why it's a second degree equation? Because in the work of the spring, you have delta L3 square. So it's S3 plus 0.5 square. So when you replace, you will end up with a second degree equation function of S3. You can solve with your calculator, determine the location at which your block will stop. Okay? Any question on this?
No.
Okay. Let us do another problem. The 17.5 kilonewton car is traveling down the 10 degrees inclined road at a speed of 6 meters per second. If the driver jams on the brakes, causing his wheels to lock, determine how far as his tires will skid on the road. The coefficient of the kinetic friction between the wheels and the rod is mu k equal to 0.5.
Just one question. أي متى UN ما بتكون 0؟
إذا منا perpendicular to motion. Okay? كل force perpendicular to motion ما بيكون عندها work.
Okay.
Okay. So in this example, always you start by drawing the free body diagram of forces. You represent all forces acting on your system. So here, for example, we have, of course, the weight. We have the normal, which is perpendicular to contact. Here we treat the car as a particle. And we have the friction force, which will oppose motion. Now, look, for the friction on cars, it can be a driving friction. It can be an opposing friction. So you will know this from the given. In this problem, you are putting your brakes on, okay? So the friction will play a role into opposing your translation, opposing your motion, okay? So your car will move down and the friction will oppose this downward motion by doing an action upward. Now, these are the forces acting on your car. What do you know about your car? You know its initial velocity. So this is state 1. You know that at state 1, the velocity of the car was 6 meters per second. And now you started to, you put the brakes on. Okay. So you will start to do a deceleration. The velocity will decrease until a certain location where the velocity will become 0. Because the question is to find the distance s before the car will stop. Okay, so at the final state, I want to find the distance as the car will move before my car will stop. So at state 2, my car will stop. This means that the velocity at state 2 is 0. My unknown is the distance traveled by the car before it will stop. So always, when you have an initial state and a final state and a certain displacement to find, think about work and energy. Okay? Now, how to find the friction force? They gave you the kinetic friction coefficient. It's a kinetic friction, so it can be calculated by mu k times n. You remember the static friction is smaller or equal to mu Sn. So I cannot know exactly its value. I calculated by writing the equation. We did a lot of calculation on the friction, on the static and kinetic friction in the Newton law. Here, because they specified that the friction is kinetic, you can directly set the friction equals to mu k times n. So to calculate F, you should calculate n. So first, how to calculate your normal reaction? Which equation you will use?
mg cosine theta.
Yeah, so you will project along this direction. Very good. Because along the perpendicular to the incline, do you have any motion? No motion along this direction. So you can call this direction y and the direction of motion x. So you can take x along the incline and y perpendicular to the incline. Okay? Since along y no motion, you can say that sum of forces along y is equal to 0. So you project your forces along y. Your normal is along y because it's perpendicular to the incline, so plus n. For your weight, the weight is doing with y an angle of 10 degrees. Why? Because as we know, the weight is vertical, okay? So it's doing 90 degrees with the horizontal. And since the angle between the incline and the horizontal is 10, then the angle between the weight and the incline is 80, okay? So the angle between the weight and the incline is 80. This means that the angle between the weight and the perpendicular to the incline, which is y, is 10 degrees. Okay? So now if you want to project the weight along y, you should do minus, because it's a negative projection, it's downward. So it's minus w cosine theta, okay? Minus w cosine of, I will erase because, okay. So this is W. This is the normal. And this is F. So we have
بس
that.
سؤال
Yes.
ليه ما أخذنا normal equal 0؟
The work of normal is 0. بس النورمال هي 0؟
لا
لا. ليش
أوكي.
نحن عايزين نجيب النورمال؟ لأنه الفريكشن فورس is function of the normal. وراح نعوز الفريكشن فورس الفاليو تبعتها نجيب الورك of friction. اوكي؟ سو لو ما عندك فريكشن ما كان في لزوم تعمل calculation للنورمال، لأنه مثل ما شفنا بهداك البروبلم the work of the normal is 0 since it's perpendicular to motion. So no need to calculate the normal if you don't have kinetic friction. But because you have kinetic friction, which is equal to mu kn, to calculate the magnitude of your friction, you should find what is the normal. Okay? And to find your normal, you project forces along the perpendicular to motion. Okay? And from this equation, you get that n equals to mg cosine of 10. And once you find the value of n, you can calculate your friction force. So you say that my friction force F is equal to mu k, which is 0.5, times mg. The weight is given already. As I gave you already the weight of the car. So times 17.5 times cosine 10. So now you can calculate the magnitude of your friction, and the value is in kilonewton because the weight is given in kilonewton. Okay? Now, once you know the value of the friction magnitude, you can now move to your second step. Your second step is to apply the principle of work and energy in order to find your unknown, which is S. Okay? So now, as we said, we will apply between the initial state, this is state 1, this is state 2. We will apply the principle of work and energy between these two states. Okay? So, the principle of work and energy will tell us that sum of work between 1 and 2 is equal to the kinetic energy at state 2 minus the kinetic energy at state 1. Okay? Now I will open a new meeting to continue. Please join with the same link.